So this question is asked in UGC NET exam 2017. Which of the following is true for computation time in insertion, deletion, and finding maximum and minimum element in a sorted array? We have to keep in mind that question is being asked for sorted array. So in sorted array, example 4, 6, 8, 10, 11, 13. This is kind of a sorted array. So what is being asked? What will be the computation time in insertion, deletion, and finding maximum and minimum element? So first we see for insertion. So we see that the array is sorted. So if we have to insert an element, suppose we have to insert 9. What we will have to first do? We will have to first find the place where 9 will be placed in this sorted array, because we can't place anywhere in the array, because array is already sorted. So after insertion the array must be sorted, so we have to find the place for 9. So this can be done using binary search algorithm. We know binary search. With this algorithm we can find any element in sorted array in log n time, where n is the number of element. So for insertion we have to first find the place where the element will be inserted. Element is to be inserted. Okay. Then another thing we have to do, suppose we find that 9 is to be placed after 8, but we can't simply put 9 here. After that we have to shift the elements also, because 10, 11, 13, these three elements will have to be shifted right side. So in shifting, the time complexity will be on, shifting the elements. So it might depend, it might be possible that the new element which is to be inserted is to be inserted after 4, or maybe initial element before the initial element. So it is possible that we might have to shift all the elements in the array. So the maximum complexity, time complexity, so worst case time complexity for shifting will be on, because in worst case we have to shift whole n elements. So this will be on and this will be O log n to search the place where the element will be inserted. If we use binary search, then it will take log n time. So finally total time complexity will be log n plus n, O log n plus O n, and as n is greater than log n, so this expression will be O n. Okay, so the time complexity in inserting an element in sorted array will be O n. Okay, now we see the time complexity for deletion. Deletion might be the case we may have given the pointer to the elements which have to be deleted. Suppose 10 is to be deleted. So if we have to given if we have been given the pointer to 10, then we just have to delete 10. But after deleting 10, we have to shift the elements to the left, or so in shifting it will take O(n) time complexity. And if we have to search, suppose pointer to 10 is not been given, simply the question says delete 10 element, delete element 10, then we first have to search the element, then delete the element. So in searching, same, if we use binary search algorithm, it will take O log n time. Then in deleting it will take O(n) time because of shifting. Okay, because of shifting. Why we have to do shift? Because the array is sorted, so we will have to shift the elements. So finally it will also take O(n) plus O log n, that will be O(n) time complexity. Because log n is less than n, so when we add this, this will be complexity of O(n), because we take worst case time complexity, and log n is less than n, so this is O(n) plus O log n equal to O(n). Now we see max element. We know this is sorted element, sorted array, so to find maximum element we will take only O(n) time. O(n) means constant times, because maximum will be, if it is ascending order, if it is in ascending order, then maximum will be last element will be maximum, and first element will be minimum. And if it is in descending order, then the max element will be first element of the array, and the min element will be the last element of the array. So this can be found in just one iteration. So the time complexity in max and min, finding max and min will be O(n). Okay, fine.